This is the video answer key for the review for Test 2 in Math 1113. Test 2 covers Units 3 and 4, which is primarily rational functions, inverse functions, exponential, and logarithmic functions. So let's see if we can get started. Question 1 says, find the horizontal asymptote for the function given below. And you're actually given a rational function. And so to find the horizontal asymptote of a rational function, you have to compare the degree, which is the highest exponent, of the numerator to the degree of the denominator. And when you make that comparison, one of three relationships can occur. Either the degree of the numerator is less than the denominator, the degree of the numerator is equal to the denominator, or the numerator is greater than the denominator. Depending upon the relationship, that determines if you have a horizontal asymptote and then how to find it. If the numerator is less than the denominator, you do have a horizontal asymptote, and the horizontal asymptote is always the x-axis, or y equals 0. If the numerator is equal to the denominator, you have a horizontal asymptote, and the horizontal asymptote is the ratio of the leading coefficients. If the numerator is greater than the denominator, there is not a horizontal asymptote. There then becomes the option you could have a slant asymptote, but we're not going to talk about that at this particular juncture. So looking at the rational function that I'm given in question 1, the degree of the numerator is 4. The degree of the denominator, which is the highest exponent, is 4. So when I compare those, numerator and denominator, I have 4 compared to 4. So 4 equals 4. Since the numerator equals the denominator, there is a horizontal asymptote, and it's equal to the ratio of the leading coefficients. Now, the leading coefficients are the numbers in front of the highest exponent. So that would be 7 over 3. So my horizontal asymptote for this particular function would be y equals 7/3. Number 2 asks us to consider the graph of the function, and the function is f of x equals x squared minus 16 equals x cubed minus 5x squared plus 4x, and it wants to know the vertical asymptotes. Before you do anything, and really I should have done it in the problem above, but I didn't. Really, before you do anything with a rational function, the first thing you should do is to simplify it, okay? So our first step here is to simplify, sort of like simplifying a fraction. That's going to require us to do some factoring. So I'm going to factor the quadratic that's in the numerator. It is a difference of two squares. It factors as x plus 4, x minus 4. In the denominator, I initially noticed that I have a common factor of x. So I'll factor that out, and I'm left with x squared minus 5x plus 4. And then I need to try to factor that trinomial there. So I still have x plus 4, x minus 4 in the numerator, my common factor of x, and then I'm going to break down the trinomial. I need a pair of numbers that will multiply to 4 but add to 5. I believe that is 4 and 1. They're both going to be negative. We have x and x. then notice that I have a common factor in the numerator and the denominator. I can divide out x minus 4 so that I have simplified my function to x plus 4 over x times x minus 1. Now, it's important to note that this x minus 4 is important. Okay, the x minus 4, if we solve for x by adding 4 to either side, we get x equals 4. And that value of x equals 4 becomes a point of discontinuity, meaning that visually on the graph, you would have like this hole in the middle of the graph at the value of 4, but you do not have a vertical asymptote at that particular point because it divides out when you simplify it. From there, then, we can determine the vertical asymptotes. The vertical asymptotes occur at the values of x that make the denominator equal 0. So the vertical asymptotes occur at the restricted values of the domain or at the values of that make the denominator 0. So I would have the fact that x equals 0 or x minus 1 equals 0. Solving for x, I find that my vertical asymptotes are x equals 0 and x equals 1. Again, the value of x equals 4, which divided out is a point of discontinuity, not a vertical asymptote. Question 3 asks us to find the inverse of the one-to-one function f of x equals the cube root of 3x minus 2. Well, first of all, it's important to note that they tell us this is a one-to-one function, so we don't have to verify that. Okay, you have to know that you have a one-to-one function in order to even have an inverse to look for. So they tell us that in the problem. Then it's a two-step process. Basically, we interchange x and y, remembering that y is the same thing as f of x, and then we solve the resulting equation for y, and when we're finished, what we have is the inverse of the function. So if I do that for this particular problem, I have x equals the cube root of 3y minus 2. Remember that the f of x is a y, and we're going to interchange x and y. And then I need to solve that equation for y, So I need to get rid of the cube root, so we're going to do that by raising both sides to the third power. So I have x to the third equals 3y minus 2. Remember, cube root and cubing are inverses, just like squaring and square root are inverses. Again, I'm trying to isolate the y, so I'm going to add 2. That gives me x cubed plus 2 equals 3y. Again, I'm trying to solve for y, so then I'm going to divide both sides by 3 so that I have x cubed plus 2 all divided by 3, and that equals y. And again, once you get it solved for y, what you have is you have f inverse. So the inverse of the function f is x cubed plus 2 all divided by 3. Question 4 also asks you to find the inverse of a 1-to-1 function. So again, it tells you initially that it is a 1-to-1 function. Remember that f of x is y. So again, following the same steps as before, we're going to interchange x and y. So I have x equals 9y minus 6 over 6y minus 7. And I'm going to make this look like a fraction. So I'm going to put the x over 1. Remember, we can make anything a fraction by putting it over 1. So I have a fraction equal to a fraction, which is called a proportion. And we solve that by cross multiplication. So I'm going to multiply x times 6y minus 7 equals 1 times 9y minus 6. Then I'm going to use the distributive property and distribute on each side. So I would have x times 6y, so that's 6xy minus 7x equals 1 times 9y is 9y, and 1 times minus 6 is minus 6. Again, keeping in mind your goal is to isolate the y, so I need to get all the y's together and everything else on the other side. So I'm going to add 7x, add 7x, so I have 6xy equals 7x plus 9y minus 6. Again, I'm trying to get all the y's together, so I'm going to subtract 9y, subtract 9y. So I have 6xy minus 9y equals 7x minus 6. So I have both the terms that have y in them on the left and everything else on the right. I notice I have a common factor of y, so I'm going to factor out that common factor of y. So I have 6x minus 9, or y times 6x minus 9 equals 7x minus 6. And then, again, I'm trying to solve for y, so I'm going to divide both sides by 6x minus 9, so that I have y equals 7x minus 6 over 6x minus 9. And again, at that point, what we found is we have found f inverse. Okay? Again, there's a lot more math involved there, so just be careful. Take it one step at a time and walk it through. All right, question 5 is a word problem, which I know a lot of you find daunting. Okay, so let's walk it through very carefully. It says the amount of simple interest earned in varies jointly with the rate of interest and the number of years t. The simple interest earned is $3.50 when the rate of interest is 2% for 0.5 year. How much simple interest in dollars will be earned when rate of interest is 4% for 0.75 years? Round answer to 1 decimal place. Okay, a couple of things here. First thing I notice is that the question says it varies jointly. Now remember, for this test, you are able to use your notes and that sort of thing. So you could go back and look up the formula, or the formula is at the beginning of the test. But in generic form, varies jointly is x equals k times y times z, where k is a constant. And you have the variables x, y, and z. So that's the generic formula. The one we have here, this first sentence kind of redefines those variables for us. It says the amount of simple interest earned, which is N, varies jointly with the rate of interest and the number of years. So N is the amount of interest, R is the rate of interest, and that was usually easy to identify because it's going to be stated as a percent, and T is the time, and usually for interest that is stated in terms of years. And again, K in the formula is a constant, and at this point we don't know what that constant value is. So the first sentence in the problem kind of gives you the formula you're going to need. Then the second sentence, okay, let me get a different color here. The second sentence kind of gives you one relationship. It says the simple interest earned is $3.50. So I'm going to write down these numbers as we go. When the rate of interest is 2% for half a year. Okay, now that sentence is going to gives us all of the information we need, and that's going to allow us to determine the value for K, or the constant. Then the third sentence is going to give us a second relationship that we can then use to figure out the value for another scenario. Okay, so it's really a two-step process. You have to first use the generic formula and the information given to find the constant to create a specific formula that we're then going to apply. Okay, so make sure you go far enough when you're working through the problem. So my first step here is going to be to find the value of my constant. So I'm going to plug into my generic formula. So I would have $3.50 equals K times my 2% interest written as a decimal times my half year. Now you probably want to get a calculator. So we have $3.50 equals K times, and I'm going to multiply that together. 0.02 times 0.5 is 0.01. Then I need to divide both sides by 0.01. So K is $3.50 divided by 0.01 is 350. So based on the information that I'm given in the first situation, I now can have a specific formula that for this problem, that N is 350 RT. Okay, so this gives me my specific formula, and then from there I use the third sentence. Let me go back up here to my third sentence. My third sentence says how much simple interest will be earned when the rate of interest is 4% for 0.75 years. Okay, so they're asking me in that scenario, in how much is the simple interest if R is 4% for 0.75 of a year. Again, remember to convert your percent to a decimal. So plugging into that specific formula, I would have N equals equals 350 times the 4% times the 0.75 of a year. Guys, at that point, it becomes a calculator problem. Okay, so we would type 350 times 0.04 times 0.75 and hit equal. And N is 10.5. The instructions ask us to round to one decimal place, so that is how we would need to express the answer. But guys, it's important that you go far enough, go all the way, walk it through one step at a time, break down the word problem one sentence at a time, and pay attention to how you're asked to round. Question 6 says, let f of x equal 4 times 1/4 raised to the x plus 2 power. This is an exponential function, and they want you to find f at 2. Guys, this is a straight, flat out plug and chug problem. They wanted me to substitute 2 into the problem wherever there's an x. So f at 2 would be 4 times 1/4 of 2 plus 2. So that gives me 4 times 1/4 to the 4th power. Now I can do that on my calculator, and I will show you how to do that in just a minute. But I'm going to walk it through in baby steps here so you can see the steps. Okay, so I would do the exponent first. So I would have 4 times 1 to the 4th power is 1. 4 to the 4th power, 4 times 4 is 16, times 4 is 64, times 4 is 256. So 4 to the 4th is 256. 4 times 1 over 256 gives me 4 over 256, and you always want to simplify your fraction. It becomes 1/64. Now again, for some of you it might be easier to do that on a calculator, so let me show you how to do that. Okay, so you have parentheses, 1 divide 4, close the parentheses, there's your 1/4, raised to the 4th power, and then we're going to multiply that times 4, and it comes out as a decimal. We want it as a fraction, so we press Math, option 1, and it gives us 1/64. Now, a decimal answer is fine, but if the choices are listed as fractions, you have to be able to convert it to a fraction. Okay, so then question 7, if we read it through, and again, it's another word problem, but guys, read it through completely first. It says Cora is saving for her son's college education. If the savings account earns 2.8% interest compounded monthly, and she wants to have $25,000 in 18 years, what must the principal amount or initial amount be? Round answer to the nearest dollar. Okay, so again, this is, if you read it through, you'll realize this is a compound interest problem, so we need our compound interest formula. The formula is A equals P times 1 plus R divided by N raised to the NT power. Now A here is your final amount. P is your principal or your initial amount. R is still the rate of interest. And again, that's typically going to be a percentage. N is the number of compoundings. How many times within a year are you going to calculate interest? I usually tell students that's going to be some kind of word that ends in ly, like monthly, annually, weekly, and T is the time. And typically for interest, we think about time in terms of years. And so we have 5 variables, and so we have to be told 4 of the 5. And so if we go back and carefully and slowly read through the problem, we should be able to identify those values. Okay, so we start out, and the second sentence, it says, if the savings account earns 2.8% interest. Okay, so it clearly lets me know that the rate of interest is 2.8%. We do need to convert that to a decimal. Remember, we divide by 100. Again, continue reading slowly. It says compounded monthly. So monthly is going to tell me the number of compounding. See that ly word? There are 12 months in a year, so we would compound it each month, so 12 times. Continuing to read, she wants to have $25,000 in 18 years. So at the end of 18 years, Cora wants to have $25,000. So be careful here, okay, because the $25,000 is your final amount. That's at the end. And the time is 18 years. And then it says, what is the principal amount? So even in this question, it lets you know that you're looking for the principal. So we've identified all of the information. We have the formula. It becomes a plug and chug. And then you have to do the math. Okay, so we would have 25,000 equals P times 1 plus R written as a decimal divided by N raised to the 12 times 18 power. Okay, so then again, if you know how to do it very carefully, you can put all of that into your calculator at one time. I personally like to do it in baby steps. Okay, so if we follow order of operations, I'm going to do this multiplication here in the exponent first. So I have 25,000 equals P times 1 plus 0.028 divided by 12 raised, and I'm going to multiply 12 times 18. Again, I definitely want to have a calculator. That's 216. Okay, so doing a walkthrough and thinking through my order of operations, okay, I would have, next I'm going to do inside the parentheses, so I have 25,000 equals P times 1 plus 0.028 divided by 12 is 0.0023333. The 3 is repeating, raised to the 216 power. So again, I'm going to show you this on my calculator. Okay, so we would do 0.028 divided by 12. Okay, then still working inside the parentheses, I need to add these two values together. So I have 25,000 equals P times 1.0023 with the 3 repeating, raised to the 216th power. Okay, so on my calculator, The 0.0023 repeating is in its brain, so I'm going to add 1, and then I need to raise that to the 216th power. I'm going to multiply 1.023 repeating times itself 216 times, and we get 1.654357826. Again, notice that I'm not rounding. You don't want to round until you get to the very last step. Okay, so at this point, we have raised this to the 216th power. So we have 25,000 equals P times 1.654357826. Again, I'm ultimately trying to solve for P. So then I'm going to divide both sides by 1.654357826. So that P will equal, so 25,000 divided by that answer is 15,111.60379. Okay, so we have 15,111.60379. Now be careful because the instructions ask you to round to the nearest dollar, which means you don't want to have a decimal place. So here's the nearest whole number. Next door is the 6. The 6 is going to bump it. So we end up with $15,112 would be the principal. Guys, let me give you a caution here. If she wants to end up with 25,000 at the end of 18 years, she's not going to start with more than 25,000. So if you do these calculations and you get some number that's greater than the 25,000, you've made a mistake, okay? So use common sense and think about the answers that you get and do they make sense. Question 8 is another interest problem. If we read it, the total amount paid on a 5-year loan was $16,000. If the interest rate was 7% compounded semi-annually, what was the principal? Round to the nearest dollar. So again, we're using our interest formula. Again, we identified what all of the letters represented in the above example. So let's go through and identify the information. It says the total amount paid on a 5-year loan. So we took out a loan that we had to pay back over a 5-year period. So my time is 5 years. The amount that I paid at the end of that 5-year period was $16,000. So my total amount that I eventually paid was $16,000. Continuing to read, it says if the interest rate was 7%, so my interest rate, or R, is 7% converted to a decimal, compounded semi-annually. Semi-annually means 2 times per year. Semi means half, so that's 2 times per year. And it says, what is the principal? And round to the nearest dollar. Okay, so again, everything, 4 of the 5 variables are given to you, and then you plug it into the formula. So we have 16,000 equals P times 1 plus 0.07 divided by 2 raised to the 2 times 5 power. Again, if you know how to do it, you can put it all into your calculator at one time. I tend to walk it through. So I'm going to multiply these numbers together as my exponents first. So 16,000 equals P times 1 plus 0.07 divided by 2 raised to the 10 power. Then I'm going to work inside the parentheses. Okay, so working inside the parentheses, I'm going to do the division. And I forgot to change colors. Sorry. Okay, so I'm going to do the division. So I have 16,000 equals P times 1 plus 0.035 to the 10th power. I did that in my head. But guys, you can go over here to your calculator. 0.07 divided by 2 is 0.035. Then again, continuing to work inside the parentheses, I'm going to do the addition. So I have 16,000 equals P times 1.035 to the 10th power. Okay, so on my calculator, I'm simply going to add 1. And then I'm going to do the exponent. Okay, so we're going to raise 1.035 to the 10th power. So I have 16,000 equals P times, okay, so let's raise that number to the 10th power. And we get 1.410598,761. Okay, so 1.410598,761. I'm then going to divide both sides by that number, 1.410598,761. So we get P equals, let's see, we do 16,000 divided by that long decimal number, and we get 11,342.70102. So P is 11,342.70102. Again, if you go back and look at the instructions, they ask you to round this to the nearest dollar. So that's no decimal. So you have a 2. Next door is a 7. It's going to bump it up. So we have $11,343 would be our principal. Again, our principal, which was our initial amount, should not be more than the final amount. All right, question 9 is a graph. Okay, it says which of the following is the graph of 3 to the negative x. Now, one of the things I would caution you about is that you pay attention to the scales on each of these graphs. And in my opinion, the easiest way to do this is going to be to create the graph on your calculator and then use what you can see on the graph to help you. Okay, so if I go out to my graphing calculator and I want to graph 3 raised to the negative x power. Okay, I notice that it comes down from the left to the right. Okay, I also can see, and if I can't see it real well, I can check it on my table, that it intersects at 0, 1, and then I can check some other points. It also has a point at negative 1, 3, negative 2, 3, so that may help me out. So when I look at the first one, even without looking at the scale, I notice that it doesn't come down from, excuse me, left to right. So it can't be the first one, just from the shape. It might be the second one. It could be the third one. It could be the fourth one. And it can't be the fifth one. Okay, because of the direction. Okay, from there then I want to look to see which one of these crosses at 0, 1. Okay, so the second option here, it does cross at 0, 1, so I'm good there. The second one crosses at 0, 2, and the third one, it also crosses at 0, 1. Okay, so then I need to narrow it down. The other point that we can focus on is it had the point negative 1, 3. So let's look at the graph. So at negative 1, we should be at negative 3. So let's look. Okay, this one, if I'm at negative 1, I'm not even to the 2. So it can't be this one. And my other option up here, if I'm at negative 1, I do intersect at 3. It's really the only choice I have left, so it has to be this one. Okay, it's just a visual inspection comparing it to what you see on your graphing calculator screen. Okay, question 10 is the graph of a logarithmic function. It's log base 3 of negative x. So again, I'm going to start out by graphing it on my graphing calculator. So I'm going to clear this one off. Now, to get to a log with a different base other than 10, we go to Math, scroll down to the option Log Base, select it by hitting Enter, and it's log base 3, then arrow, and I want to do negative x. And I'm going to hit Graph. Okay, so again, I can see here that it goes kind of from left to right. So if I use that information first, okay, and it's on the left side of the graph. So this one doesn't work. This one doesn't work. This one doesn't work. So I'm really down to either none of these or the last option. So I need to check about this last option. So I want to see about some of the key points. So if I hit my table, I should have a point at negative 1, 0 and negative 3, 1. So let's see. I have negative 1, 0, and I also have negative 3, 1. So this one actually works, so it's this. Now, had this one not worked, you do have the choice here of none of these. Okay, number 11 says, what is the range of this particular function? Now, hopefully you recognize this as an exponential function. And the domain of an exponential function, by definition, is all real numbers. but the range depends upon what base you have and what transformations. Have you shifted it up, down, left, right, and so forth. So the easiest way to see this is going to be to look at the graph. So if I want to look at the graph of this function, I'm going to take this equation and I'm going to put it into my calculator. Okay, so I would have the negative 5 divide 2 times my base of 3, which is raised to the exponent of x plus 2, and then we have minus 1. And I'm going to hit graph. Okay, and I'm looking for the range. The range corresponds to the y. Visually, it looks like I'm coming up from negative infinity, and I never get above negative 1. Now, if you don't believe that, then you could look at the table, okay, and just look how that you never, you're getting closer and closer and closer to negative 1, but then it stays at negative 1. So my range for this particular problem, now remember, range corresponds to the y values, and the easiest thing to do is look at the graph, and it goes from negative infinity to negative 1, but we don't include the negative 1 because that's where your horizontal asymptote is going to be. Okay, number 12 asks you to find the domain of the function f of x equals the natural log of 5 minus x. Okay, so first of all, hopefully you recognize this as a logarithmic function, and you remember that the domain corresponds to the x values. So you could also do this by looking at a graph, but for a logarithmic function, the way it is defined, the argument here, the 5 minus x, your argument is what it's called, must always be greater than 0. In other words, it must always be positive, and it cannot be exactly 0. So I could look at the graph, and I'll show you how to do that. So if I go out to do the natural log, okay, we use the ln button of 5 minus x, you get something that looks like this. It comes in from the left, and it doesn't go beyond negative 5. Or excuse me, not negative 5, but positive 5. Again, you can look at it on the table and see that once we get to positive 5, we begin getting errors. Okay, so we can't put in any values that are bigger than 5. So visually, we can see that our domain goes from negative infinity to 5, but we can't use 5. Now again, I can verify that if I don't want to use the graph. I know that 5 minus x has to be greater than 0. And if I solve that inequality for x, remembering that when I divide by this negative, I have to flip my inequality symbol, we get the expression that x is less than 5. So I can choose anything from negative infinity up to, but not including 5. Okay, so there's a couple of ways to do some of these problems. All right, 13 says write the complete expanded expression equivalent to natural log of 6x plus 5 divided by x plus 4. Okay, so this problem is asking you to use your properties of logarithms to expand it. And then sometimes really with questions 13 and 14 where you're either expanding or possibly condensing into a single logarithm, that skill becomes important as you move forward into your higher level math classes, especially in calculus, because sometimes when you have a fraction looking something another or something that's got multiple terms, it's easier to deal with in a different format, especially in calculus. So you want to be able to apply those properties. So immediately what I notice here is that I have division, and the property related to division says that division can be rewritten as subtraction. So this would become the natural log of 6x plus 5 minus the natural log of x plus 4. It's almost like you're distributing. I'm distributing the natural log to the numerator and denominator, and we're connecting them through subtraction. Now you have to remember that 6x plus 5 or even x plus 4 is sort of like a couple. They're connected by that plus sign and you can't separate them apart. So that is as far as we can go with that particular expansion. With 14, you're trying to go the other way, okay? You're trying to condense into a single logarithm those three terms. And so again, you have to apply the properties of logarithms. The first thing I notice is that I have these coefficients in front of the log, which we can apply the property and those go back and become exponents. So this is rewritten as the natural log of t squared plus the natural log of z to the fifth minus natural log of t. From there, I see that I have things that are added and subtracted together, and I'm going to work left to right, just like we do with any math problem. We work left to right. So working left to right, natural log t squared plus natural log of z to the fifth. Addition becomes multiplication if you go back and look at the properties. Okay, so I'm going to have the natural log of t squared times z to the fifth minus natural log of t. Then I have two terms that are connected by a minus. Minus or subtract is rewritten as division. So I have the natural log of t squared z to the fifth over t. And I'm almost home free, but as was the case with any fraction, guys, you always want to simplify the fraction. So notice that we have a t squared and a t. So I can divide out that t, and I'm left with the natural log of t times z to the fifth. Now, guys, you do realize that you could write z to the fifth times t as well. The order of your variables doesn't matter, because remember, multiplication is commutative, that the order can be changed. Okay, the last two questions are application problems again. And so they're word problems again, which I know several of you find daunting. Okay, but again, everything you need is given in the problem. And in these two problems, you're also actually given the formula. For example, right here in the middle of this problem, they give you the formula that you need. And they also explain what the variables are for the most part. Okay, so it gives you the formula if you take your time to look. And I'm going to read that second sentence. It says the function f of t equals c e to the negative kt plus 60 represents the situation where T is the time in minutes. Okay, so T is time, and it's specifically in minutes. C is the initial temperature of the object. K is a constant, and it doesn't say so, but F of T is the final temp. Okay, so if I go back, that identifies, there's my formula. I've identified the what each letter or variable represents. So let's see. I'm going to read the question. A small object with an initial temperature of 135 degrees Fahrenheit is dropped into a tub with a temperature of 60 degrees Fahrenheit. The function f of t equals ce to the negative kt plus 60 represents the situation where t is time in minutes, c is the initial temperature, and k is a constant. After 6 minutes, the object has a temperature of 85 degrees Fahrenheit. What is the approximate value of K? Round to 4 decimal places. Okay, so here again, if we go back and we read slowly, it says an initial temperature of 135 degrees Fahrenheit. So my initial temperature for this object is 135 degrees. And the tub with a temperature of 60 degrees Fahrenheit. Okay, then it gives us the formula. Then it says after 6 minutes, so after 6 minutes, minutes represents my time, so my time is 6. The object has a temperature of 85 degrees. So kind of the final temperature here is that it is 85 degrees after those 6 minutes. So my final temp is 85 degrees. Okay, what is the approximate value of K? So the question itself lets me know, hey, you're looking for K. Now some of you may be worried about, what about this 60 degrees Fahrenheit? Guys, the 60 degrees Fahrenheit is taken into consideration in the formula here. See this plus 60. Okay, so don't get caught up and all frantic about that. All right, so let's see what we got here. I have all of my values. I'm going to plug them in to the formula. So we would have 85 degrees is my final temp equals 135 times e to the negative k times 6 plus 60. Okay, I've plugged in all the numbers into my formula, and I'm ultimately trying to find k. So I'm going to try to isolate the k, so I'm going to subtract 60 from either side, which gives me 25 equals 135 e to the negative 6k. Again, I'm trying to get the k by itself, so I'm going to divide by 135. So I have 25 over 135 equals e to the negative 6k. Now I could simplify that fraction a little bit since both those numbers would divide by 5. So I can simplify my fraction. I can divide by 5, divide by 5. So we get 5 over 27 equals e to the negative 6k. I then need to eliminate my logarithm base of e. To do that, I'm going to take the natural log of both sides, and I'm using a natural log because it's base e. So I'm going to have the natural log of 5/27 equals, Okay, remember that natural log and base e are inverses. They divide out. So then we have negative 6k. And our goal, remember, is to solve for k. So I've managed to get it kind of almost by itself. So then I have to divide both sides by negative 6. So k equals the natural log of 5/27 divided by negative 6. And I'm going to use my calculator to do those calculations. Okay, so we have natural log of 5 divide 27. I'm going to get that answer and then divide it by negative 6. And we get 0.2810664,923. So I have 0.2810664,923. The instructions said to round to 4 decimal places. So 1, 2, 3, 4. Next door is the 6. The 6 is going to bump it. So my final answer is 0.2811. And one more. It says the intensity of sound is measured on the decibel scale, represented by dB. The equation dB equals 10 times log I represents the decibel level, where I is the ratio of the sound to the human hearing threshold. A noise registers a decibel level of 29. What is the value of I? And round to the nearest whole number. So again, in this problem, they've given us the formula that we need to use. Okay, they've told us that the decibel level is 29, and they've actually asked us, sorry about that, for I. Okay, so let's plug and chug. So we have 29 equals 10 times the log of I. Okay, so then I'm going to divide both sides by 10. I'm trying to get the I by itself, remember. So that gives me 2.9 equals log I. Okay, so then I need to eliminate log base 10. So I'm going to do 10 base 10. So I have 10 to the 2.9 equals, again, exponential base 10, logarithm base 10 are inverses, and that equals I. And so then I can go out and do that on my calculator. So I would have 10 raised to the 2.9 power, which gives me 794.3282347. Okay, so we get 794.3282347. It said to round, let me see, what did it say? Round to the nearest whole number. So whole number means no decimal. So I have a 4. Next door is a 3. It's going to leave it alone. So we have 794 would be the I. And And there is the video answer key for the review for test 2.